Okay. Now we're good. I'm going to back this up just a little bit. Oh, please don't be fuzzy. Okay. We're going to talk about parametric relations and inverses today. Like I said, we're just going to focus on the parametric relations here to begin with. And I want you guys to consider a situation here for me. Let's say plane. Sketch out the path that an object is going to be moving at. Okay, it's not going to be a function. Okay, we're going to kind of not worry so much about functions for a minute, and just consider like if, let's say, looking down at an object that was just kind of moving around in some way. Maybe it was like an airplane, and I had an aerial view of this airplane from up top, and I could see the path that it was taking. Okay, or I was looking at like the path. If I was some kind of conservationist, and I was looking at, like, I was really interested in squirrels, and I was looking down, and I had a camera set up, and I could see the path that the squirrels were running around in the park or something like that. Okay, so I'm just tracing out some kind of a path, some kind of an object, animal, whatever, is moving at. Okay, so it kind of starts here and swings around and kind of does something like that. So it started here and it went there. So maybe, like I said, like this is, you know, like the aerial view of like a park, and there's this little squirrel running around. And so I was like timing it and seeing where the squirrel was at any given time in the park. Okay, well, maybe we'll just stick with the squirrel example here. Okay, so so this point right here would be we call it the initial point, and this point over here maybe was the where the terminal point was. So there's a flow to this where it has a starting point and ending point, so it has to go in this direction. Okay, so the squirrel was moving in this kind of a direction towards the terminal point. Okay, and so what I did then, let's say, was I took this path that I had and I kind of gridded it out. So put it on a coordinate plane then and said, all right, so if I'm doing some measurements, let's say these are some measurements in feet. So it's kind of a small little area. So maybe this is 1 foot, 2 foot, 3 feet, 4 feet. So within this little 4-foot area, the squirrel scampered in a quick little circle like that. And then I'd have, you know, feet going this direction as well. So 1, 2, 3, 4, 5, 6. Okay. And so I got 3 pieces of information here then on my squirrel that I'm looking at. Number 1, its x coordinate. Okay, because I can track anywhere on the curve. So let's say like the squirrel was right here in this little dip here. So what would be its x-coordinate in that little dip? Well, somewhere about 4.5 maybe. Okay, and then the second piece of information I have would be the y-coordinate of the squirrel at any place on the curve. So at that point, then the maybe it's like 2.8 or something is the y-coordinate for that particular point. And then the third piece of information that I have is time, because I have the squirrel running in this arc. I know that's the path that it took, but I also know, because I've been timing it, where the squirrel was when along there. Okay, so my initial point would be like t equals 0, time equals 0, and then depending on how fast the squirrel was moving, I can give you any other time along there. Okay, so at the initial point, t equals 0. And then the terminal point, this would be just whenever time stops. So it depends on how long it took the squirrel to do its little scampering around there. Okay, so this idea of having 3 different things will allow us to create a set of equations that describes the path of this. Okay. So what we're going to have are two equations. One equation that has actually two functions. One is a function for x, and another function is a function for y, both of which are based off of time. We talked about function, we talked about input and output, right? In parametric equations, let's just talk about x first. My x equation, the input of the x equation is time. Okay, so if I were able to calculate an x equation for this little squirrel, then I would be able to tell you what its x coordinate was if you were able to tell me how much time had passed. You input the time, I give you the x coordinate. Okay? And same thing for y. I'd have a second equation for y. You tell me how much time has passed, I plug it in, I can tell you what the y coordinate of the squirrel is at that time. So there are two equations that describe one path, because I have this third thing to work with, time. Time is my input for both, and then my outputs are x and y. So I can get ordered pairs. I can get an x-y pair for any given point in time. So let's say after maybe 1 second, the squirrel is right here. So this would be our t equals 1 second position on the curve. Okay? And so at that point, if you kind of look at the scale, so I'll come out here. So at t equals 1, looks like x is approximately, what, about 5.5 maybe? And y is approximately, yeah, maybe like 2.8 or something. So if we think of them as these input-output equations where the input is time for each one, a way of describing this, you could say x of 1 equals 5.5 and y of 1 equals 2.8. Okay, the input is the t, the first one, x of t. So x of 1 is about 5.5. Y of 1 is about 2.8. Okay? So this is kind of the concept. This is what we're going to be doing with this. Now, we're not going to be looking at any paths that are quite this complex, because based on the background math that we have, it's going to be difficult to come up with some parametric equations that truly trace that thing out. So the graphs we're going to have will look somewhat more normal. They'll look like shapes you're used to seeing and not do anything too terribly interesting at this point. But it's the first time you guys have seen this, so I don't want to get too complicated with that. But does this kind of make sense, though, as far as what it is? The input-output idea? I give you time. We get a position, an x and a y together. Okay, because that's what we're going to do next. We're going to take parametric equations. I'm going to give you the equations first, and then we're going to see if we can come up with some ordered pairs for it, and then start to kind of plot it out a little bit.